Yeah, hello dear students. You are welcome to session 5 of core mathematics for senior high school. So under this session we'll be treating the topic number bases. Right. Okay, so let's look at the outline. So by the end of this lesson you should be able to convert numbers from base 10 to other bases, convert from other bases to base 10, convert from one non-decimal base to another, perform operations on number bases other than base 10, and also solve equations involving number bases. Alright, so let's begin now. Okay, so number bases. Now, all along the numbers that you've been using in mathematics, as in 1, 2, 3, 4, 5, and so on and so forth. Now all these numbers are in base 10. Alright, so the usual base in which all numbers are written, right, is the base 10, right, also known as the decimal base. Alright, but then aside base 10 we have other number bases, right? So we have base 2, base 3, base 4, base 5. So the least number base is base 2, right? So we don't have base 1 and we don't have negative number bases as well, right? So it's from base 2 upwards, right? And for any given number base, the number of that base does not form part of the digit used under that base, right? So that is one important point to note as far as number bases is concerned. Right, so it means that if we are working in base 2, the only digit involved will be 0 and 1. Right, if we are working in base 5, the only digit involved will be 0, 1, 2, 3, and 4. So 5 should not be part of the digit under base 5. Neither should 2 be part of the digits involved in base 2. Right, so let's now look at how we can convert from other bases to base 10. Right, so if we have a foreign currency, we can convert it into a local currency, right? And also we can convert a local currency to a foreign currency. Alright, so let's look at how we can convert from other bases to the standard base 10. Alright, so we are going to use this example here to go through the steps, these steps, right? So if we are asked to convert 10111 base 2 to base 10, how do we go about it, right? So let's take a look at the steps involved. So step 1 says list the individual digits of the given number in order as they appear in a row. Right, so you are going to spread out the digits. Right, so 1 0 1 1 1. You spread the digit out. Then you pick each digit and multiply it by the base, right? And then you put them in bracket as well. So when I pick this one, I'll multiply by the base, which is 2. Right, so 1 times 2. Then I bring the addition sign, and I pick the next digit 0. I multiply by the same base of 2, and I put it in bracket. Then I come to this one, multiply by 2, put it in bracket. This one, multiply by 2, put in bracket, and then finally this one, multiply by 2 and put in bracket. So take or multiply each digit by the base and then put them in bracket, right? And then you connect them with the addition sign, right? You connect the brackets with the addition sign. Now the next thing to do is you are going to raise the base in each bracket to an exponent. Right, starting with 0 from your extreme right to your extreme left. So what I'm going to do is I'm going to start from my extreme right here. Right, you realize that each bracket contains the number 2, which is actually the base, right? So what you do is that you're going to raise the base in each bracket to a power, right, starting with 0 from your right to your left in that ascending order. So here is going to be 1 times 2 to the power 0, 1 times 2 to the power 1, 1 times 2 to the power 2, 0 times 2 to the power 3, and then 1 times 2 to the power 4. right? So it's from your right to your left in that increasing order. So from here you just solve the bracket, right? So let's first find the result of the powers, right? So what is 2 to the power 4? It is 16. What is 2 to the power 3? It is 8, right? 2 to the power 2 is 4, 2 to the power 1 is 2, and then 2 to the power 0 is 1, right? So any number with the exponent of 0 is 1, right? So from here we can simply multiply. So what is 1 times 16? The answer is 16. 0 times 8 is 0. 0 times any number is 0, right? 1 times 4 is 4. 1 times 2 is 2. 1 times 1 is 1. So from here we just add the numbers, right? So 16 plus 0 plus 4 plus 2 plus 1 gives us 23, right? So it means that 10111 base 2 is equivalent to 23 in base 10, right? So this is a simple process we are going to go through in converting from other bases to the standard base, which is base 10, right? So let's look at another example here. So we are going to apply these basic steps or these basic principles, right? So we have to convert the number 457 base 8 to the decimal base. So the decimal base is the same as base 10, right? So the first thing is to spread out the digits, right? So 457, right? And then you multiply each digit by what? By the base, and then you put them in brackets, right? So you're going to have 4 times 8 plus 5 times 8 plus 7 times 8. And then you are going to raise the base in each bracket to a power, right? Starting with 0, right? But then you're going to start from your extreme right towards your extreme left. So here is going to be 7 times 8 to the power 0, 5 times 8 to the power 1, and then 4 times 8 to the power 2, right? And then we solve the powers. So 8 squared gives us 64, 8 to the power 1 gives us 8, 8 to the power 0 gives us 1. And then we multiply each bracket, right? So 4 times 64 will give us 256, 5 times 8 is 40, and then 7 times 1 is 7. So 256 plus 40 plus 7 gives us a total of 303, right? So it means that 457 base 8 in base 10 is 303, right? So that is how to convert a number in a different base to base 10. I believe it's clear, right? Okay, so still on conversion from other bases to base 10. Actually base 10 is not the highest number base, right? We have other number bases beyond base 10, right? So we have base 11 and then base 12, right? We have other bases, we have other higher number bases as well, right? Alright, so let's look at some special characters or some special numbers that are involved in higher number bases like base 11 and base 12, right? Now you remember I told you that for any given number base, the highest digit under that particular base must be 1 less than that particular base. So if we are treating base 2, or if you are working in base 2, the highest digit should be 1. If it's base 6, the highest digit should be 5, right? So always the maximum digit that can be found or that is involved under any given base should be 1 less than that particular base, right? So it means that for base 11 the highest digit should be 10, because 10 is 1 less than 11. And for base 12 the highest digit should be what? Should be 11. But then you see 10 is actually a 2-digit number, 11 is also a 2-digit number. So if we are to write the 10, right, in base 11, we wouldn't know whether we are writing 10 as in 2 separate digits as 10 or 10 as a digit on its own, right? In order to avoid this tendency or this confusion, some special characters are used to represent the numbers 10 and 11 in base 11 and base 12. So for 10, we use the letter T, a capital T, to represent 10 in base 11 and in base 12. In order to avoid the confusion of you not knowing whether it is 10 as a digit or it is 1 0 as in two separate digits, right? So we use the letter T, capital T, to represent 10. Under base 12, we use the letter capital E to represent the number 11. So whenever you see E, it means it is 11 as a digit in base 12. Whenever you see T, it is a digit, the digit 10 in base 11 or base 12, right? So let's look at this example here. So we have to convert ET43 base 12 to base 10. So when you see something like this E represents 11 and then this T represents 10, right? But then we couldn't have written it as 11 1 0 as in 1 1 1 0 4 3. Otherwise we wouldn't know whether it is 1 0 as in 1 as a digit and then 0, or 10 as a single digit. I believe you get it. Yeah. So how do you convert ET43 base 4 to base 10? Well, going by the same approach. So you are going to pick each of the digits and then you multiply by what? By the base. So the first digit here is 11. So you're going to have 11 times 12. We put it in brackets. The next digit is T10. So 10 times 12, put it in brackets. The next digit is 4. So 4 times 12. And then the last digit is 3. So 3 times 12. Then we raise the base in each bracket to a power, starting with 0 from the extreme right to the extreme left. So here is going to be 3 times 12 to the power 0, 4 times 12 to the power 1, and then 10 times 12 to the power 2. Right, and then here will be 11 times 12 to the power 3. So 12 to the power 3 is 1728, 12 to the power 2 is 144, 12 to the power 1 is 12, 12 to the power 0 is 1. So the next thing is to multiply the brackets, right? So 11 times 1728 gives us 19,008. 10 times 144 gives us 1,440. 4 times 12 gives us 48. 3 times 1 gives us 12. Sorry, 3 times 1 gives us 3, right? So we add these 4 digits and the result is 20,499. Therefore, ET43 base 12 is equivalent to 20,499 base 10, right? So similarly here we have to convert 8T4 base 11 to base 10. So we start with the 8 and we multiply by the base 11. So 8 times 11 plus this T is 10, right? So 10 times 11 plus 4 times 11. Then we raise the bases to powers, right? So here is going to be 4 times 11 to the power 0, 10 times 11 to the power 1, 8 times 11 to the power 2. Right, so 11 to the power 2 is 121, 11 to the power 1 is 11, 11 to the power 0 is 1. Right, so the next thing is to multiply each bracket. So 8 times 121 is 968, 10 times 11 is 110, 4 times 1 is 4. So 968 plus 110 plus 4 gives us a total of 1082. Right, and this means that 8T4 base 11 is equivalent to 1082 base 10. Right, so that is how to convert from other bases to base 10. Right, so let's now look at the flip side. So let's look at converting from base 10 to other bases. Right, so let's use this example to go through the steps here. Right, so we have to convert 57 base 10 to base 4. Right, so the first thing is create 3 columns. Right, so we have the 3 columns here, 1 2 3, and each column has something that it would cater for. Alright, so for the first column we are going to write the number in the new base, or let me say, yeah, the new base here is 4. Right, so we are going to write 4 in the first column. So the first column always caters for the new base that you are converting into. So here we have to convert 57 base 10 to base 4. So the base is 4. So we are going to write 4 here. That's the first column. Now the second column caters for the number in base 10, which is 57 here, right? And then the final column, or the third column, caters for the remainder, right? So we are going to simply apply the principle of division here, right? So we are going to simply divide. We are going to divide the number in base 10 by the new base, right? So we have to divide the number in base 10 by the new base and write the quotient under the second column. Now the quotient is the result of dividing the number in the new base, the number in base 10 by the new base. Or generally, when you talk of a quotient, let me give this example. 7 divided by 2 is 3, right? So 3 becomes the quotient. So the quotient is simply the result of dividing a number by another number, right? So we are going to be dividing the number in base 10 by the new base, and then we'll keep the quotient under the second column, and then the remainder gotten after dividing the number in base 10 by the new base is placed under the third column here, right? So that is the basic principle we are going to apply in converting from base 10 to other bases, right? So you first create your 3 columns. The first column caters for the new base, right? The second column caters for the number in base 10, and then the third column caters for the remainder. Then you divide the number in base 10 by the new base, keep the quotient under the second column, and then the remainder after dividing, we are going to keep it under the third column here, right? So what is 57 divided by 4? The answer is 14, right? So 14 times 4 is what? It's 56. Then we keep the remainder here. So the remainder is what? Is 1. Good. Now we are going to keep on, okay, we are going to keep on dividing the number, or let's say the quotient gotten under the second column. We are going to keep dividing this quotient by the new base, right? So it says that repeat the division of each new quotient by the base until the new quotient is 0. So here we had 14 as our quotient, or as the result of dividing 57 by 4 is 14. Then we repeat the same 4. Okay, we are going to repeat the same 4. So what is 14 divided by 4? It is 3. So you keep the quotient under the second column once again, and the remainder under the third column. So 4 by 3 is 12. Remainder what? Remainder 2. So I'm going to keep the 2 here. Good. Now 4 into 3 is what? Is 0. Remainder 3. Right? So once we get the new quotient to be 0, we stop, and then we now read and write the recorded remainders from the bottom to the top, right, to obtain the number in the new base, right? So basically we are going to read them upward this way. So the result is going to be 3, 2, 1, 3, 2, 1, right? So that is how to convert from base 10 to other bases. So let's look at this example here. We have to convert 15 to base 2. Now whenever you don't see any base or any subscript, aside or beside the number, the base is base 10, because we said base 10 is a standard base in which all numbers are written, right? So it presupposes that if you don't see any base at all, if you don't see any subscript, then it is assumed that it is in base 10, right? So we create the 3 columns, and then we put the new base in the first column, that is 2, the number in base 10 in the second column, and then remainder in the third column, right? So what is 15 divided by 2? It is 7. Remainder 1. And then we repeat the same 2 here, and then we divide the 7 by the 2 again, right? So what is 7 divided by 2? It is 3, right? Remainder 1 again. What is 3 divided by 2? It is 1. Remainder 1. What is 2 divided by 1? Sorry, what is 1 divided by 2? it is 0 remainder 1. Alright, so our result is going to be, so you start reading from the bottom to the top, right? So 1 1 1 1 base 2, right? 1 1 1 base 2, right? So 15 base 10 is equivalent to 1 1 1 1 base 2, right? So that is how to convert a number in base 10 to other bases, right? So just go through these simple steps. Alright, okay, let me draw your attention to something worth noting. Now whenever the quotient becomes less than the base, right, you may decide to stop, and then you start reading from that last quotient. You move towards the right and then you move upward. Or in other words, whenever the quotient is less than the new base, whenever you divide that lesser quotient by the base, the quotient should be 0, right? And then the remainder will be the same as this last quotient here, right? So you may as well decide to pause here or end here, and then you read your new base from this last quotient, which is less than the new base, and then you shift towards the right and then you move upward. So here too we can do same. Instead of bringing 0 down here and then writing 3 as a remainder, so that we read it from the bottom to the top, we may decide to end here and then we can read it from this last quotient, which is less than the new base of 4, right? So we move towards the right and then we move upward. So 3 2 and then 1. I believe you get me. Yeah, it's the same thing. You would arrive at the same answer, right? Okay. Alright, so let's now look at how we can convert between non-decimal bases. Alright, so we've looked at how to convert from base 10 to other bases and from other bases to base 10. So what if you are converting from one non-decimal base to another non-decimal base? Now, there is no clear-cut or straightforward approach in doing that, right? So because of that, we are going to solve it in 2 ways. First of all, you convert the non-decimal base number, right? You first convert it to base 10. Alright, you first convert it to base 10. Then you convert the number in base 10 to the required base. Right? So assuming you have to convert a number in base 8 to base 5. Since you can't straight away do that, you first convert the number in base 8 to base 10. And then subsequently you convert the converted number in base 10 to base 5. Right, so let's take a look at this example. So we have to convert 67 base 8 to a number in base 5. So the first thing to do is convert 67 to base 10, right, to the common base or to the standard base. So we are going to get 6 times 8 plus 7 times 8, right? So here becomes to the power 0 to the power 1, right? So 6 times 8 is 48, 7 times 1 is 7, right? So giving us 55 base 10, right? So it means that 67 base 8 is the same as 55 base 10, but then we have to convert 67 base 8 to base 5 rather, not base 10. But because we know how to convert from base 10 to other bases, then we can likewise convert 55 base 10 to base 5. Alright, so we are going to use the second approach that we just saw, right? Converting from base 10 to a different base. So the first column caters for the new base 5. Second column is the number in base 10, 55, and then the remainder. Right, so 55 divided by 5 is 11, remainder 0. Right, 11 divided by 5 is 2, remainder 1. And then since 2 is less than the 5, we may decide to pause and then read it as 210. Or we can say that 5 goes into 2 0 times, right? Remainder 0. Right, it's the same thing. Then you read from the bottom to the top. So it's still 210 base 5. Right, so this tells you that 67 base 8 is equivalent to 210 base 5. I believe you get it. So you first convert the number to base 10. So here we have 55, and then you convert the number in base 10 to the required base of 5. I believe you get it. Yeah.